Hi, everyone. My name is Arl Lomel. I'm a researcher on translation and AI. I work for CSA Research, which is a market research firm focusing on those topics. And today I'm going to be talking about a really interesting video I saw that was put up on YouTube by Giordano Scarciotti, an Italian researcher, who interviewed three individuals about the development of what are called memristors. Now, if you haven't heard of those, I hadn't heard of them before I saw the video. You're not alone, obviously, but very, very interesting and insightful interviews with three individuals. The first one was Leon Chua, who had first predicted memristors in 1971. Put them out as an idea, sort of didn't really go anywhere, and he moved on. But then in 2008, Stan Williams at HP Labs actually succeeded in making this component. And so Garciotto talked with him as well. And lastly, he interviewed Themis Podromakis, who's a leading researcher on neuromorphic AI, who's at the University of Edinburgh. Now, a little bit of background very quickly. For years, there were three fundamental components of electronic circuits. There were resistors, capacitors, and inductors. Chua had proposed the memristor back in 1971, and it was the idea of a component that would store a voltage and allow it to be retrieved. So it has a memory of this component, of the voltage, and then you can do calculations and other things on it. Now, that may not sound like a big deal, but it would have been difficult to build. It took, over 30 years to actually produce a working memristor. Okay. Now, where this becomes really important is in the context of AI. And by the way, memristors exist. You can buy chips that have arrays of them. They're not huge arrays, not like GPUs with billions of transistors or whatever the numbers are at. But chips with tens of thousands of memristors exist. So these are something that's readily available, just not in huge arrays. Where it becomes significant in the context of AI is that we've heard for years about how AI supposedly thinks just like human brains do. Now, that's always been overstated. I'm always pointing this out to people. LLMs have more in common with the visual ganglia of fruit flies. So that's not to downplay what they are. They're very technologically sophisticated, but they aren't working like human brains. So in the context of AI, where that matters is that LLMs store memory, the weights of the model, in one area, and then the processing is done on those inputs somewhere else. Okay, you say, so what? Well, we know that human brains do not make this distinction between memory and processing. It all occurs roughly in the same layer. And so one of the points that Podromakis mentioned in there, in the interviews, is that we would probably get better AI results if you were actually operating on the weights. Now, significantly, memristors, because they're storing voltage, are storing a scalar value, not just an on-off number. So they're not binary like the logic that we see in any sort of algorithmic approach we have today. Instead, they're storing, a voltage, which could be at any, level of granularity you want. Now, there's going to be precision issues in recalling the voltage, but if you wanted to store, 1.3 volts and distinguish that from 1.2, that could be done. So this makes it really powerful in that you can operate on the memory in the same layer as the memory. This is something that might actually lead in the direction of AGI, artificial general intelligence, although that's being obviously speculative. But highly significant in this too is that memristors consume much less power. So according to Podromakis, you could see something like the equivalent of an LLM that takes megawatts to run could run on as little as 20 watts using memristor technology, which would put this in the realm of something like running an entire LLM on a device like a mobile phone. So it's, we have all this real potential to address the power consumption issue, to improve the output that are associated with LLMs, making them more relevant and better adapted to remembering things. And then this addresses another issue, which I don't think has gotten enough attention, and that's that LLMs are fundamentally unreliable. What does that mean? Well, basically it means that if you have a request to an LLM and you ask it 100 times, you might get 80, 90 different responses, and they could be contradictory responses. It won't necessarily remember what it was doing the last time you asked it the question, and so for translation or other applications, you just end up with real inconsistency. So I think with the development of LLM equivalents that use memristors, you'd see the potential of much more reliable, repeatable, consistent AI experience using much less power and addressing many of the theoretical limitations that we see with LLMs. So anyway, I strongly encourage you to go watch the video. It's really, I think, fascinating, and to realize that there still are fundamental discoveries that can be made in fields like electrical engineering that can have profound impacts, not just as downstream things, but groundbreaking fundamental research. And so I think we'll see more about this in coming years as neuromorphic AI that really does work like human brains, starts to take hold and become more powerful. Anyway, again, I encourage you to watch the video. It's fascinating, 45 minutes long, but very well done. Anyway, have a great day.